Paper 1, question 7, part A. She told Anne is paying into her pension. She's paying €400 to start and then €5 each month until she retires. What you need to pick out here is 400, 5 per month, and she receives an additional payment of 65% total sum invested. So, part A, complete the table showing Anne's monthly contribution for the period shown. So the first month's 400, so she adds 5 the next month, so 4, 5, 10, 4, 15. So for the 12th month, that's 11 months after the first month. So it'll just be 5 times 11, so 5 11s plus 400, which is 455. And then again for the 24, 23 5s plus 400 is 515. Then part 2, find in terms of N a formula that gives the value of Anne's monthly contributions in the nth month of the scheme. So this is now in patterns. So we look at the log table. T of N equals A plus N minus 1 times D. So we put it down first of all. T of N equals A plus N minus 1 times D. So A is our starting amount. So we started off with 400 plus N, we don't know, minus 1. D's our difference, so 5. So it'll be 400. 5 times N is 5N. 5 times minus 1 is minus 5. So your formula for T of N will be 5N plus 395. So it's just 400 to go. Then part 3, find in terms of N a formula that gives the value of Anne's total pension contributions for the first N months of the scheme. If you want the total pension contributions, you have to add up. So you're going to use your S of N formula for the sum. So S of N equals N over 2 times by 2A plus N minus 1D. So we have the same same A and D as before, so fill them in. So it's N over 2 brackets 2 times A, which is our first term, which is 400, plus N minus 1 times by D, which is our difference. So that goes to N over 2. 2 times 400 is 800, plus 5 times N is 5N, minus 1 times 5 is minus 5. N over 2, 5N, 800 take away 5 is plus 795. So S of N equals N over 2 times by 5N plus 795. Then part 4, using your formula or otherwise, find the total value of Anne's pension fund on the date of her retirement. Start the question, we're told Anne wishes to retire in 30 years' time. Working out in months here, so you'll need to change 30 years to months. So you do 30 times 12, which will give you 360 months. And that's going to be your N. So, using your formula from above, N, which is 360, over 2, times by 5N, so 5 times 360, plus 795. 360 divided by 2 will give you 180. 5 times 360 will be 1,800 plus 795. Next we're going to add them up. So 1,800 plus 795 is 2,900. 2,595, sorry. So it's 180 times by 2,595. Times that in our calculator. It's 467,100. On a retirement, and will have saved for €167,100. Then, part B. Beth agrees to invest a fixed amount of money every year in order to generate a pension fund for when she retires. She assumes that in the long run, money can be invested at an inflated, adjusted annual rate of 4%. This means you're dealing with compound interest. So, in the table below, write down the value of Beth's contributions of €P after each of the time interval shown. So, if you're dealing with compound interest, F, which is your final amount, is equal to P times by 1 plus I to the power of T. P you don't know. 1 never changes. I is your interest. 4%. Write it as a decimal, so 0.04. After 1 year, it's just times by 1. So it'll be P times by 1.04 power 1. So what you need to write down. So it's P times 1.04. Then after 5 years, it'll be the same. It'll be P times by 1.045. And then after 2 years, it's P times by 1.04 to the power of T. So it's just your years is the power. Part 2. The total value of the pension fund after 2 years can be represented by V equals V for value, whatever she invested, times by 1.04 for the first year, 1.04 times 2 for the second year, 1.04 times 3 for the third year, to the power 3, plus so on, and 1.04 to power times to the power of T for the last year. State whether the total value of the fund can be represented by the sum of the arithmetic or geometric sequence. Justify your answer. Well, the arithmetic we know is adding sequence, and geometric is multiplying or a constant number being multiplied. Arithmetic can't be because you're not adding the same amount every time. If it was just 1.04 all the time, but it's 1.04 to different powers. Therefore, it must be a geometric sequence. The reason why it's multiples of 4, so it's powers of 4. The increasing ratio is just what it's gone up by. So multiplies 1.04 is the increasing. The total value of Beth's pension fund after 2 years can also be calculated using the formula V, so the final value, equal to P, so what you invested to begin with, times by 1 plus I for your interest, times again by 1 plus I power T, so total years you invested, take away 1 all over I for the interest. Where I is annual rate of interest. We know I, for question, is 4%. If Beth makes 30 annual payments of $6,000 at the start of each year, from now until her retirement, what will the value of her pension fund be when she retires? So I is 4%. P is the $6,000 because that's what she's investing each year. T will be 30 because you're told Anne and Beth wish to retire in 30 years' time. T equals 30. So now we're going to fill what we know into the formula. V, so our value at the end will be P, so 6,000. Bracket 1 doesn't change. Plus 4% is a decimal, so 0.04. Close bracket. Open another bracket. And it's 1 plus 0.04, which is the power of T, which is 30 years. Take away 1. All over 0.04. I'll put this into my calculator to work it out. So, fraction, start off with that. 6,000. Then bracket 1 plus 0.04 close my bracket, open a bracket, open a second bracket, and it's 1 plus 0.04, close bracket, power of 30, take away 1, all over 0.04. So my value after the end will be 349,970. It says correct the nearest euro. So it will be 349,970 euro. The last one, it says, give a reason why Beth's pension fund will be substantially less than Anne's pension fund after 30 years. If we look, Beth is just going to invest the 6,000 each year, while Anne started off with 400 the first, and it's going up then a £5 per month each month for 30 years. Anne's contributions increase each month. Anne's pension contributions increase each month. And over time they become quite large, so the hands become quite large. Meaning she invests more.